So, guys.
Absolutely, yes.
So today I'm going to talk with you about improper integrals and the infinite sequences. My lecture will be in two parts. First part will be in about improper integrals, and the second part will be infinite sequences. So firstly, as I said, improper integrals. Yeah. So, what is the improper integrals, guys? What we will learn with you, we'll study with you today, guys. So, as you know, guys, from calculus 1, you know that how to find area of the objects. For example, if we cut this graph, guys, from here, you know that how to find area of this object. Do you remember, guys, how we find this one?
Yes. Integral.
Yeah, we use here integral. We need to just find integral of ln x over x squared, and then from 1 up to 6, yeah? From 1 up to 6. So we know that how to find this one, but we didn't talk about if what will be if we let that our graph goes to infinite, guys. What will be graph of this function, guys? Or what will be, for example, if you choose this function, guys, what will be graph of this function? Or what will be half part of this graph? So this one approach to infinite or negative infinite, yeah. This one, for example, what will be area? So I said graph, not correctly, guys. I mean that what will be area of this object, guys? So area of this object will be what, guys? Here. If we know that when we have finite domain, then we can find area of this object. But we didn't talk about when our domain is infinite, guys, or when our range infinite. Yeah. Here we claim that our domain is infinite, and here we claim that our range goes to infinite, and today we will talk about these areas of these regions, guys. Okay, and as I believe that you will understand how to find areas of this object. Okay, guys. So what do you think, guys? Okay, what do you think? What will be area of this object? For example, I have a function y is equal to e of power minus x over 2. What do you think? Has this region infinite area or finite area? What do you think? So since this one goes to up infinite, and we know that between x-axis and between these grams we have the very little regions. So what do you think? What will be area of this object?
I think we
Infinite.
should use limit, maybe.
So I think that it would approach to some number, yeah.
Okay, yeah, guys, you're right. This region exactly for this function will be finite. Let's find area of this region, guys. How we find? Okay, so you know that we let just our region is finite. What will be in the case if our region finite, guys? Let's cut our region up to here. For example, let's define this one as B, and you know that, guys, to find area of this object, what we need to do? We need to find integral from 0 up to b of the function of this function, yeah. So it means that I wrote here this one. Okay, so if we find integral of this function, we get minus 2 e of power minus x over 2, because you know that integral of this one equal to this one. To check it, you need to just find derivative of this object and you will get this function. Okay, you need to put here 0 and we put here b. Then we have what, guys? Then we put firstly b instead of x, and then after we need to put instead of x 0. So e of power 0 will be 1, and here we have 2. But since we have here minus 2 and by formula we have minus, it will be plus, so we have plus 2. And you know that what is this one? We just put instead of b, instead of x, our b. Okay, so if our domain is finite, we know that depending on b, guys, our area will be this one. Am I right? Okay, and but our aim to find area of this object. How we find it? To find it, guys, what we need to do? We need to let, guys, this b should approach where, guys? This b should approach to infinite, yeah? So, guys, so it means that we just let, guys, our b approach to infinite. It means that our b approach to infinite, and then what we need to do? We need to just let. It means that we need to let limit b approach to infinite. Or so since we know that for any b area of this object is equal to this function, we just find limit of a b. We define area depending on b, guys, as function, guys. So we just let b approach to infinity, and then we put instead of a b this our area, guys, dependent on b. So if you find limit of this object, you will get what? You will get 2. So because I think it's clear for you, because e of power minus b over 2 minus 2 means that what? Means that minus 2 over e of power b over 2, yeah? So because since b approach to infinite, this one goes also infinite, and since minus 2 is a constant number, and it will be more less, and it will be it goes to 0. So we let that this one is 0 when b approach to 0 infinite. So our limit will be just 2. Okay, guys, and what does it mean? Area of this object defined by this function, and if you find area of this region, colored region, we can say that area of this region is equal to what, guys? Equal to 2. So now we found area of this object. Okay. Any questions here?
No questions.
Okay, guys. So this kind of integrals called improper integrals, guys. So we have in integral, if we have infinite, guys, or minus infinite, we call this kind of integrals as improper integrals. Okay, next one. Here definition of improper integrals of type 1. And for example, we have if our function f of x is in continuous function on the given interval from a up to infinite, then if we want to find integral of this function, we find its integral by using this formula. So as we did before, guys, we use this method. So firstly, we find integral from a up to b. After we just let that b approach to infinite, and then we find its limit. Also, if our function f of x is continuous on this interval from minus infinite up to b, then integral of this function will be what? Limit. In this case, guys, we since we have here firstly minus infinite, we just change minus infinite by a. After we let that limit approach to limit of this function when a approach to minus infinite, and we'll find this limit, and it will be answer of this integral. And in the third case, as you see here, we have minus infinite and plus infinite. So if our function continues in this interval, what we do, guys? Since we know that these two formulas, we use this one, guys, these two, guys. So it means that we choose any real number between minus infinite and infinite, guys. And what we do, guys? We just let that from minus infinite up to c, where our f of c has value, yeah? And from c up to infinite, yeah? And we can rewrite by using these two formulas, guys, this one will be what, guys? Limit here c here a approach to infinite. Here I just changed minus infinite by a. I wrote here minus in, so here minus infinite, yeah, up to c f of x dx. Can you say me what will be here?
Limit
B approaches to infinite.
Limit b, yeah?
Yes.
Yeah, b approach to infinite from c up to b f of x dx. Right, guys? Cool. Okay, guys. And this one is the method of the finding integrals, or when we have on interval from minus up to infinite, or when we have infinites in our intervals, guys. Okay, in each case, guys, if in each case, you know that we have limit, guys, as you know, and in limit we say that our integral, improper integral, converges if this limit exists, guys. So it means that if this limit constant number, then we can say that our improper integral converges. So if this limit does not exist, so it means that what? It means that it can be minus infinite or plus infinite, yeah? If just it does not exist, yeah? In this case, we can say that our integral is diverges. So we say that improper integral diverges. That's all. So if it has value, we can say that it is converges. If the limit fails to exist, we say that it is diverges. I think it's clear for you. And here one more example for so as you see here, firstly we consider this graph, guys, and let's find. Now we know that what's the improper integral, and we know that method of finding these integrals. Let's find integral of this function. What will be area of this object, guys, when we let that our function approach to our x approach to infinite, yeah? So as you see here, so you know that firstly we let that we just find from integral from 1 up to b, as you see here, and we firstly find integral of this object ln x over x squared, and to find integral of this object we used here integration by part, and our solution was this function. Okay, guys, and this one, when our interval is finite, then we can find our area of this object. But our aim to find area of the when we let b approach to infinite, yeah? So it means that what? It means that we want to find integral of this function, guys. And to find integral of this function, what we need to do? We need to write by the definition, first one, yeah? First definition, we write here limit b approach to infinite and the integral from 1 up to b ln x over x squared dx. And as you know, as we found here, guys, integral of this object is equal to this one. We just write instead of this function, instead of this integral, this function, guys. Okay, and if we find limit of this function when b approach to infinite, you know that 1 over b approach to 0 when b approach to infinite. Here, what we have here, guys, since you know that, guys, so we just write here 0, here 1, and we need to find just a limit of this function. And as you studied in calculus 1, to find if your if you have function f of x and g of x, and of course first derivative of g of x is not equal to 0, then you can find you can use to find limit of this function L'Hopital rule. Do you remember, guys? So let here x, yeah, x approach to infinite,
yes.
And Here we just use L'Hopital rule. It means that we need to firstly find the derivative of b by b is equal to 1, and the derivative of ln b by b will be 1 over b. So we just found derivatives of these two functions, and when we let b approach to infinite, this object goes to 0 because 1 over b goes to 0. So it means that this part is equal to 0, and the 0 plus 1 will be 1. So it means that so let me write, yeah, area of this object when we let b approach to infinite, when this one goes to infinite, it means that area of this object is equal to just 1. That's all. Okay, and we say that this improper integral converges because limit of this object exists. Yeah. Okay. Any questions here?
No questions.
What will be the limit of this function, guys? Oh, sorry. What will be area of this function, of this region?
С минусом плюс.
So you see here our this part of our function approach to infinite, and this part of our function also approach to infinite. And how we find? Again, we use our definitions of improper integrals. And you know that here our region, what is our region? From minus infinite. So what's our interval? From minus infinite up to infinite, yeah? So it means that we have from minus infinite up to infinite. It means that we need to use this third definition, yeah? We have minus infinite and plus infinite. It means that we need to find some constant number between minus infinite and the infinite, and we can use our improper definitions of our previous definitions of our improper integrals. Okay, guys. So it means that we need to find integral of this function. Okay, how we find? To find it, what we do, guys, we need to find between minus infinite up to infinite some number, or we just write here c, yeah, from minus infinite up to c, and from c up to infinite. Okay, you see here we just have what, guys? From minus infinite up to infinite, we choose our c as 0, guys, and we can choose any number because firstly we see here our function is continuous between minus infinite and plus infinite, and we choose any number, guys. Here not you can choose here, for example, 1 if you want. You can choose or 1 over 2. It is your choice here, guys. And we in book we choose here 0, guys. It means that what? It means that we need to find integral from minus infinite up to 0 and from 0 up to plus infinite. Okay. And you know that this one is our second definition. Yeah, this one is our first definition. And again, what we do, guys, here? Again, we do next. Yeah, we need to use limit, guys, to minus infinite. You need to write here a, and if we find limit and the integrals of these functions, what we get, guys? And since we have here 1 over 1 plus x squared, it will be what, guys, here? Arctangents. This one means that not 1 over tangent, guys. This one means that arctangents. And the arctangent is x, and we need to put 0 and a. If you put here 0, we have arctangent 0, and if you put here arctangent a, yeah. And since arctangent 0 equal to 0, we write here this one. And what will be here, guys? So arctangents, when our arctangents, what will be limit of this object, yeah? a approach to minus infinite. Here says minus infinite. How we determine it is equal to minus p over 2, guys? So, do you know what is the graph of our arctangents, guys? Do you know what is the graph of tangents, guys?
Yes.
So here p over
Yes.
2, yeah. Here p over 2 minus p over 2, guys. So graph of our tangents will be here. We have asymptote, yeah. Here also we have asymptote, and it means that our graph never cross this asymptote. Okay. So here says what, guys? If we let a approach to infinite, so it means that what? If we let, so since arctangents means that what, guys? Inverse our function tangents, yeah? It means that what? If we let y approach to infinite, it means that in the case of arctangents, we need to get x, yeah? In the case of tangents, if we let x approach to infinite, it means that what will be if we let x approach to infinite in the case of tangents? So it's diverges, yeah. I think it does not exist its limit. Okay, guys. So in the case of arctangents, guys, what we need to do? We need to rotate this graph, guys. In this case, yeah, we need to rotate our graph in this case. So in this case, we'll write here x, here y, and let's write here. So this one will be our asymptote. Here will be p over 2, and here will be p over 2 minus, yeah. And I think if we rotate this one here, what we have? So yeah, this one. Here we have asymptote, yeah. Is it correct? No. I need to change because, yeah. 1 minute, guys. Here I need to write this one. Graph of my function will be in this case, yeah. So here I have asymptote. This graph is a graph of function over arc tangents x. This one is our tangents x, and this one is our arctangents x. And as you see, if we let, in the case of arctangents, this one is arctangents, if our x approach to minus infinite, yeah, our graph approach to a, guys, to minus p over 2. So we have here minus p over 2. So it means that limit of arctangents a when a approach to minus infinite will be minus p over 2. And since we have here minus will be plus, and our integral of this part, so it means that integral of this part is equal to p over 2. Can you see me what will be integral of the second part? So it means that what, guys? It means that integral area of the left part, guys, here will equal to p over 2 when our graph x approach to infinity. So what will be area of this part?
Torso.
Right part.
Torso.
Yeah, similar.
Same
because,
as first.
yeah, here because we have what, guys? Here symmetric function, yeah. So that we can claim that this one is also p over 2. Okay. So here, as you see again, they use it again this part, and they found limit, and as you see here, they found p over 2. And to find area of the whole region, we need to add left part and the right part, and we get just p. As you see, area of this object is equal to p. So it's interesting, yeah, because you have this function, and if you find integral from minus infinite up to infinite, you will get just p. Before we see what, guys, in p in the circle, guys, yeah. Now you can see p in the areas guys. Okay. Okay, I think it's clear for you. Do you need some comments or do you have some questions? I think it's clear for you. Okay, next. Okay, and can you say what will be is this improper integral converges or diverges? Can you say me? This
Converges.
one is converges, yeah.
Converges.
Because limit of this object exists, or integral of this object exists, guys. Okay. Okay. Here, our question is this one, guys. Here, if we have function 1 over x of power p, and for what values of p does the integral converge? When we have interval from 1 up to infinity. There is a solution. So let's find again, to find you know that to find integral from 1 up to infinite, again we need to find firstly integral of from 1 up to b, and if we find integral of this function, we get this one, defined integral. Yeah, we put here a 1 and b. Yeah, we get this one. And what we do next, to find integral of this one from 1 up to infinite. Here, note that here we define that p not equal to 1. Okay, after we will consider later we will consider the case of p is equal to 1. So here what we have 1 over x of power p, and by definition of improper integral, we write here limit p approach to infinite from 1 up to b dx over x of power p, and we know that what is the integral of this object, and we put this one here, and then we just find the limit of this one. And as you see here, if our p, depending on p, guys, if our p more than 1, so it means that here, if our p more than 1, our this one will be what, guys? If our p more than 1, it means that here we have positive power, and it means that 1 over, when our b approach to infinity, this will be 0, yeah? So that limit, since this one is 0, here minus 1, and if we multiply minus 1 by this one, we just change here, change places of the 1 and the minus p. Okay, so if our p more than 1, we get this limit. If our p less than 1, it means that here we have negative number, and b will be in power negative, and we can write b here. We can write in reverse form. It means that we have constant number b, and since b approach to infinite, it means that this limit also approach to infinite, and we get infinite. It means that when our p less than 1, then we have a limit infinite, and the integral of this function also will be infinite. Okay, what we can say here, guys, we can say that if p more than 1, our function converges, and its value will be this one. And if our p will be less than 1, our function diverges, and it will be infinite. Okay, and it remains to consider that when the case p is equal to 1. Okay, so let's write what will be if our p is equal to 1, guys. So it means that here we put instead of p 1, yeah. It means that we have here just x, yeah, because x of power 1 is equal to x, yeah. So let's find integral of this function. To find integral of this function, we again use definition of improper integral, and we again use limit here. We just write here b, and then we found limit. Firstly, we found integral of 1 over x, it will be ln x, and if we find put b and 1, yeah, we have ln b minus ln 1, and if you find limit of this function, this one will be equal to what, guys? This one will be equal to 0, but this one will be what, guys? Since b approach to infinite, it means that the value of ln b ln b, yeah, also approach to infinity. It means that in the case of p is equal to 1, this improper integral diverges. Okay, in just only in this case our improper integral converges, just in the case of p more than 1. That's all.